So wave is nothing but the disturbance created to a steady state of matter. A wave which requires material medium for its propagation is called as mechanical waves. Particles of the medium oscillate about their mean position perpendicular to the direction of propagation is called as transverse wave. Non-mechanical waves, the wave which doesn't require any material medium and the wave that can even travel in vacuum is an example for non-mechanical waves. Hello everyone, welcome to session 1 of chapter 15 Waves. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the previous chapter called Oscillation, we have learnt about some basic terms related to oscillations. We have learnt about the time period, frequency, amplitude and various terms. We have also learnt about the simple harmonic motion and many more interesting concepts. In this chapter, waves, we do have few concepts which were there in the chapter oscillations, and we have to study about the continued part of the chapter called oscillations. And here in this chapter, we are going to understand the basic concepts of waves. What is the meaning of propagation? How does a wave propagates? What is the basic meaning of the term called waves? What are the types? And many more interesting concepts. So let's begin with the introduction concept. So first thing, waves. So what is the meaning of waves? We might have all observed when we drop a stone into a still water, there will be a formation of ripples in it. And the ripples will form for long distance even though if we drop a single stone. Why is it so? So there the energy is getting transferred from one particle to another particle in the form of disturbance. And that is the result for the cause of waves. So wave is nothing but the disturbance created to a steady state of matter. Example, dropping of pebbles to a silent water. So pebble means stone. If we drop a stone into a still water, a stagnant water, we can observe the formation of ripples, that is the formation of waves, and that is due to the disturbance created in it. And the form or the sort of disturbance is called as waves. So what are the types of waves? So waves are of two types, mechanical waves and non-mechanical waves. So what is the meaning of mechanical wave? A wave which requires material medium for its propagation is called as mechanical waves. For example, we need a material medium for the propagation of sound, and it is the example for mechanical waves. Non-mechanical waves, the wave which doesn't require any material medium and the wave that can even travel in vacuum is an example for non-mechanical waves. So the next type of wave is the transverse wave. One of the very important concept in the chapter called waves, transverse wave. We need to differentiate between the transverse wave and longitudinal waves, which is very important question examination point of view. But what is transverse wave? Particles of the medium oscillate about their mean position perpendicular to the direction of propagation is called as transverse wave. The meaning of propagation is the motion. So, for example, I have a wave like this and the direction of propagation is along this direction. Here, the particles of the wave vibrate in its own position or in its mean position, and the vibration is perpendicular to the direction of propagation. Say for example, this is the direction of propagation and the particles of the wave vibrate about its mean position perpendicular to the direction of its propagation is called as transverse wave. So when the wave is propagating in this direction, the particles of the wave vibrates about its mean position and the direction of vibration is perpendicular to the direction of propagation. Such type of wave is called as transverse wave. But what about longitudinal wave? So longitudinal wave is nothing but a wave in which the particle of the medium oscillates about their mean position along the direction of propagation. Say for example, this is the direction of propagation. Example for longitudinal wave is a sound wave. See here, the wave is propagating in this direction, but so these are the particles which are undergoing vibration and they are undergoing a rarefaction, a compression, rarefaction, compression, rarefaction and compression successively, and the direction of the vibration of these particles are along the direction of propagation. They are compressing and getting rarefaction, compressing and expanding. So this phenomena is taking place along the direction of propagation of wave, and such type of wave is called as longitudinal wave. Example for longitudinal wave is sound wave. So let us now understand what are the basic components of transverse wave. We have come to know about the types of waves clearly, that is transverse wave, longitudinal wave. So what are the basic components of transverse wave? So it requires amplitude. What is the meaning of amplitude? Amplitude is nothing but when a wave propagates in a medium, the maximum displacement of a particle. So for example, if this is the wave propagating in a medium, so here it is the mean position of a particle. This is the maximum displacement of a particle. The maximum displacement Ymax, I'll call it as Ymax, is nothing but the amplitude. So amplitude is basically the maximum displacement of a particle from its mean position when the wave is propagating in a medium is called as amplitude. Then what is the meaning of wave period? We have also studied about all these terms in the previous chapter called oscillations. What is wave period? Wave period is the time during which one complete wave is set up in the medium. Time taken for one complete wave means it consists of one crest and one trough. So the time required for a wave or one complete wave to set up in a medium is called as wave period. So our next term is wave frequency. What is wave frequency? Wave frequency is nothing but the number of waves set up in a medium in 1 second. It is same as our time period what we have studied in the chapter called oscillation. Number of oscillation that takes place in 1 second is called as the time period of oscillation. Similarly, the number of waves set up in a medium in 1 second is called as wave frequency. Here we need to understand one more important term called phase. So what is phase? Phase of a vibrating particle at any instant indicates its state of vibration, which will give us an idea about its position. The position of a particle and its state of vibration can be explained by a term called phase. So our next important term is wavelength. What is the meaning of wavelength? The name clearly says wavelength, which means the distance between two consecutive particles in the medium which are vibrating in same phase, or we can also define it as the distance between two consecutive crests or the distance between two consecutive troughs is called as wavelength, and it is denoted by the term called lambda. So next we have wave velocity. Wave velocity is nothing but the distance travelled by wave in 1 second, because we know that velocity is nothing but distance divided by time taken, and wave velocity we are defining that is nothing but the distance travelled by wave in 1 second is nothing but wave velocity. So now we came to know about all the basic terms that related with the concept called waves. Let us now derive the relation between these terms, that is velocity, frequency and wavelength of a wave. Velocity is given by the term v, frequency of wave is f and wavelength is lambda. We need to derive the relation between wave velocity, wave frequency and wavelength. For that, we have considered a wave of wavelength lambda and frequency f propagating through a medium with velocity v. So now the wave velocity is the distance travelled by the wave in 1 second. We know that the velocity formula that is given by distance travelled in 1 second, that is distance divided by time taken. So what is distance here? The distance is nothing but the wavelength. The wave travel in 1 second gives us the concept of wavelength. Here the distance travelled by a wave is equal to wavelength in time t. So therefore we can write distance is nothing but wavelength and time is nothing but t. Here we have v is equal to lambda divided by t. But we know that 1 by t, or the reciprocal of time period, is nothing but frequency. So in the place of 1 divided by t, I can substitute v is equal to 1 by t. I have t is in the denominator, so it is 1 by t, which is equal to f, and we get the relation v is equal to f lambda. This is very important examination point of view. You can expect it for 2 marks, and this is the relation for wave velocity, wave frequency and wavelength, that is v is equal to f lambda. Now let's move on to important concept, that is progressive wave. So what is the meaning of progressive wave? We need to understand its characteristics before. So we need to understand its characteristics first. So what is progressive wave? Wave is nothing but a disturbance, as we all know. A disturbance which propagates continuously in a medium in the same direction with constant amplitude. If the wave is propagating in a medium continuously with constant amplitude, you can observe here the amplitude is constant, and such type of wave is called as progressive wave. So, as I mentioned before, the characteristics of progressive wave is very important to understand. So, let us understand one by one. The wave is propagated through the medium by repeated and periodic vibration of particles about their mean position. As the definition says, the progressive wave propagates in a medium with constant amplitude continuously. So, to get continuous propagation, we need the particles of the medium to vibrate repeatedly and periodically. So, here one of the characteristics says that the wave is propagated through the medium by the repeated and periodic vibration of particles about their mean position. Only then the continuous propagation of wave is possible, and there is a transfer of energy in the direction of propagation. Since the wave is traveling in same direction with constant amplitude, it carries energy. The transfer of energy takes place in the direction of propagation, and energy is transferred from one particle to another particle. As we have understood the example of dropping a stone into water, as I explained about the ripples formation for long distance, that is because of the energy transfer from one particle to another particle, one particle to another particle. Same way here also energy is transferred from one particle to another particle in the propagation. So, these waves propagate with constant velocity known as wave velocity, which is different for different particles. The velocity will remain constant for same particles, but it is different for different particles. All particles vibrate with same amplitude and same frequency. So, progressive wave says that it moves in the same direction with constant amplitude. So, all the particles of the medium, they vibrate with same amplitude and same frequency, and different particles vibrate in different phases. So, it is not like all the particles should vibrate in the same phase. One particle may vibrate here and the other particle may vibrate here in this phase, and the other particle may vibrate in the other phase. So, it says that the particles of the medium, when it is propagating, when the wave is propagating, different particles can vibrate in different phases, but all particles vibrate with same amplitude and frequency. These are the characteristics of progressive wave, which is again a very important examination point of view. So, dear children, in this session, we have learnt about the introductory part of the chapter called waves, where we have come across the basic terms related waves and also an important expression that relates wave velocity, frequency and wavelength. And also we have come to know about the progressive wave and its characteristics. In the next session, we'll learn some more interesting concepts. Until then, keep learning all of you. Thank you.